Sure. Sorry, I'm in your way here. I have to read this. So, Jim Steenburgh is a professor of atmospheric sciences at the University of Utah with teaching and research interests spanning mountain weather and climate, winter storms, and weather analysis and forecasting. He's a fellow of the American Meteorological Society. Thank you. And let's see, where am I? Let's see. And a recipient of the University of Utah Distinguished Teaching Award. Oh, this is a lot easier. Okay. He led the development of numerical and statistical forecast systems for the 2002 Olympic Winter Games and served as a Fulbright Scholar at the University of Innsbruck in 2019. Known as Professor Powder on the social media platform X, Steenburgh's passions for meteorology, snow, and skiing are abundantly evident in his book, Secrets of the Greatest Snow on Earth. Now it's a second edition with its popular blog, Wasatch Weather Weenies, which has attracted more than 5 million page views from snow and mountain weather enthusiasts. By the way, we do have the book up here, but it's the first edition, I believe, and the second edition is available somewhere. So without further ado, I'm going to let Jim take over. Thank you.
Thank you. And everybody's kind of coming in. I feel like when I was a kid and at church, they just made everybody move into the center of the aisle. But I don't know if that's even possible right now. But it's great to be here with the standing room audience. So this talk is really based on my book, Secrets of the Greatest Snow on Earth, and just a little bit of background. I've been in Utah for 30 years. I grew up in upstate New York, and I did my graduate work in Seattle at the University of Washington. Then I came to the University of Utah in 1995. And I spent a lot of time skiing, either riding a chairlift at the resort or on the skin track in the backcountry. As soon as people find out you're a meteorologist, they start asking you lots of questions. Is Utah snow the greatest on earth? Why does it snow more at Alta than at Park City? All these sorts of things. And this book is based on all of those questions. That's where the idea for it came from. So first, I want to talk about what the secrets of the greatest snow on earth are. And a little bit of history. Dave Hanscom is in the audience tonight. He didn't know I was going to single him out. Dave, if you can just wave. He'll be embarrassed when I say this, but Dave is a legend of the Nordic community. And I'd written almost all the book, but I really wanted to include at the beginning of it a story of the history of the phrase greatest snow on earth. Where did it come from? And you might recall maybe 15 years ago or so, the Ringling Brothers and Barnum and Bailey Circus sued the state of Utah over the state of Utah's use of greatest snow on earth. They considered it trademark infringement on greatest show on earth. And I thought I would look. I figured, well, given all the money and all the lawyers involved, somebody must have figured it out. So I went through all the court documents. Turns out nobody knew where it came from. So I decided to call Dave. And Dave said he didn't know where it came from either, but he thought I could contact a guy named Mike Korologos, and Mike might know where it came from. And like most academics, I hate cold calling people. So I hadn't contacted Mike for the longest time, but I was at a function at the Utah Museum of Natural History. There were about 1,000 people there. And who's standing next to me with a name tag on, but a guy that said Mike Korologos? That's what it said on the tag. So I struck up a conversation with him, and he said, oh, my brother came up with it, right? And I'm like, oh, yeah, tell me another story. Yeah, my brother Tom, I'll send you his email. So he did. Tom passed away just last year, but he was a pretty high-powered individual. I think he was U.S. ambassador to Belgium at one point in time. He was involved in 300 Senate confirmations for, I think, judges. And so he seemed like a pretty unimpeachable person. He said, yes, I came up with it. It was around 1959 or 1960, and the Ringling Brothers and Barnum and Bailey Circus was in town. And I thought, greatest show on earth, greatest snow on earth. So I decided, I went to the Marriott Library. This is before they digitized the Salt Lake Tribune, and I spent about an hour every morning before I went to work going through the microfilm trying to find his article. And after an incredible amount of work, I found it. So this is the original use of the phrase greatest snow on earth. It was in a supplement for the Salt Lake Tribune, the Home magazine it's called. And it came out in December 4th, 1960. And in it, Tom wrote, the Intermountain folk will tell you that the winds blowing from the west leave the wet, sticky snows in the Sierras. When storms reach the Intermountain Ranges, only the most perfect dry powder is left. Everybody's laughing because where's that been all year, right? That's just a sprinkling of what you find in this vast scenic country that is the Intermountain area. And he goes on and describes it. And finally, he says that's the extent of the Intermountains Big Top, which supports this real, true greatest snow on Earth. And that was really the birth of the legend and one of the most successful slogans, I think, really in the outdoor industry in the United States. Well, conventional wisdom. Why is Utah snow the greatest on Earth? And the conventional wisdom are things like this. I pulled these out of a couple of like Powder Magazine or websites. Things like the greatest snow on Earth is more than a catchy slogan. It's a scientific fact that Utah snow is lighter and drier. Or because of the high salt content of the lake, storm clouds create a unique type of snow that is particularly light and dry. Experts call it the lightest, driest snow anywhere. We have a phrase that we like to use as scientists to describe phrases like this, and it's called bullshit, okay? And none of these things are actually true. There's a lot of mythology behind Utah snow. And so, one of the dirty little secrets of Utah snow is it's not exceptionally dry. On average, the water content of snow at Alta ski area is about 8.4%. But if you go to Colorado, most of Colorado gets drier snow on average. Parts of Montana get drier snow on average. So they actually get drier snow than Utah, okay? But there's another secret, and what I call the powder skiing reality. Ed LaChapelle was a snow and avalanche researcher that worked at Alta in the 60s and the early 70s. He probably is considered the grandfather of kind of avalanche research and avalanche mitigation techniques here in the United States. He probably knew more about snow than anybody. He has this nice paper from 1962 in which he writes, "The best deep powder skiing is not found in the lightest snow, but rather in snow with enough body to provide good flotation for the running ski." And the real secrets of the greatest snow on Earth are three things. One is abundant snowfall. So, Colorado gets drier snow, but have you looked at their base depths very much? Now, I know we're pretty bad this year, but they tend to get a lot less snow than Utah. And if you want to ski powder, you need to go someplace where it snows a lot. The second piece is Utah's climatology is biased towards lots of Goldilocks storms. These are storms that aren't too big and they're not too small, but they're just right. You really need about 10 inches of snow before you really start to get ski flotation. On the other hand, you don't want 30 or 40 inches of snow because then the avalanche danger is too high. If you go to places like the Sierras, they do get heavier snow, but they also tends to come in these big multi-day storm cycles. It's really hard to get out and enjoy the snow there. But here we get lots of these Goldilocks storms. And then finally, the other key pieces here is we get lots of right side up snow. If you want good ski flotation, what you really want are storms that start out warm, producing higher density snow, and then they get colder with time, producing lower density snow. We call that right side up snow because the driest snow sits on top of the higher density snow, and that's optimal for ski flotation. On the other hand, if it goes the other way around, say it starts out cold and it gets warmer with time, then you tend to get higher density snow on top of lower density snow. And in that type of snowpack, you tend to have skis that want to dive and submerge. So it turns out Alta is one of these places in the world that's really got this in spades. And that's the real secrets of the greatest snow on Earth, are those three things. So I thought I'd spend a little bit of time talking about Wasatch microclimates. I haven't been to Park City at all this year, and I'm amazed at how little snow there is over here. We have almost as much in Salt Lake City on the East Bench as you do here. So I thought I would talk a little bit about why that's the case. And I want to say that I'm not the first person to do this. In doing the research for my book, I found this photograph, which is of Brighton Basin from 1935. And it was taken by a man named S.D. Green, who was a meteorologist for what was then the U.S. Weather Bureau, so the predecessor for the National Weather Service. And that year he wrote that skiers will eventually find that the heads of the Cottonwood Canyons offer the best skiing to be found in the Wasatch Mountains. And Green was a backcountry skier who used to start here in Park City and then ski over to Brighton and stay overnight in the Wasatch Mountain hut that's there and then ski out the next day. So he was the first backcountry skiing meteorologist, okay, here in Utah, so to speak. And, it is really true that the high terrain around Little Cottonwood Canyon does really get a lot more snow than a lot of other parts of the Wasatch. Does this have a pointer on it or not? Okay, I'll wing it then. So if you look at, on the right-hand side is a map of the average annual snowfall here in the Wasatch Mountains. Alta at their observing site that's at 9,600 feet or so. They've been collecting data since the early 1980s, and they average about 550 inches of snow there. But then when you move into the lee side, Park City Ridgeline, for example, the average, say, at the top of the Jupiter Bowl would be closer to maybe 400 inches. And by the time you get down here in town, it's dropped down quite a bit more to maybe around 150 inches of snow a year. And one of the reasons for this is the shape of the Central Wasatch Range. Yeah.
What was AF twin?
Oh, that's the American Fork Twin. So that's the peak that sits right above Snowbird. So if you're skiing at Snowbird and you get off the tram, the higher terrain that's just to the south there, that's the American Fork Twin.
And that's the most snow?
It probably is, but nobody knows because nobody measures up there and the wind blows really hard. But yeah, probably snowfall in the Wasatch maximizes on the high ridge that's between American Fork Canyon and Little Cottonwood Canyon, which is what this suggests. So this particular estimate that I have is about 700 inches at over 11,000 feet on the American Fork Twin. The question is why? The magic of the cottonwoods, okay? And part of the reason why has to do with the shape of the Central Wasatch. So if you go up to the northern Wasatch, the Snow Basin, the Wasatch are really, really narrow, okay? But then when you come down here and you get south of Parley's Canyon, the Wasatch get a little bit wider, quite a bit wider, in fact. And not only are they wider, but their highest terrain is not running from north-south, but it's on these two ridges that run from east-west, and that is the Alpine Ridge and the Cottonwood Ridge between that flank Little Cottonwood Canyon. And what this means is that it doesn't matter what direction the flow comes from, it has to get forced up and over that high terrain. So Alta sees the largest diversity of storms anywhere in the Wasatch Range. They're famous for like powder and northwesterly flow, but if you look at their climatology, they also get a decent amount of snow in southwesterly flow. They even get snow sometimes in southeasterly flow. So they're always getting something. They're very near the crest of the Wasatch. So they're always getting this local flow enhancement. When you get here to Park City, though, you're in what we call the precipitation shadow. So most of the snow that you get here in town is what we call spillover. These are snowflakes that have actually grown probably on the windward side of the Wasatch. They've been pushed aloft and they've been carried by the prevailing wind and they fall out downstream. So you're kind of living on the leftovers. Alta gets the main course, okay? So this is just a picture that I took this at Park City Mountain Resort. This was in late April, when a poor snow year. But this is the kind of thing that where you can kind of visualize it. So we have snow that's falling on the Wasatch Crest, but we're getting spillover, and then you get downslope here under the Park City side of the mountain. And in certain situations, you don't get a cloud shadow. You're just in snow, and that's all you're getting. But sometimes you can be in the cloud shadow here. So that's another reason why, like, for example, Round Valley, for example, doesn't get anywhere near as much snow as even what you have here right in town. It's a pretty sharp climate transition. It makes a big difference as you drive from the east to the west towards the mountains. So, but there are some times when Park City actually gets more snow than Alta. And there's a couple of situations where this happens. And that's one of the best is situations when the climatological westerly flow, the northwesterly flow, you're in the lee, it's a storm situation where we might have southerly flow or southeasterly flow, or even easterly flow. There's a closed low, say, just to the south. And in that case, the Wasatch back temporarily becomes the windward side of the Wasatch. This is where the upslope is. Okay, or Deer Valley does really well sometimes in southerly flow situations. So those are situations where the local flow basically is favoring this side of the mountains to get more snow. And we haven't had a lot of those cases this year, but there was one pretty good event where Deer Valley did really well and did even better than Alta. So a lot of people also ask me, like, you know, where are the other great places to go skiing? And so I have a section in the book where I look at, actually 2 chapters in the new one, where I'm looking at some of the best snow climates around the world, sometimes for skiing or just for scientific reasons, okay? And I like to tell people a couple of my favorite snow climates. I grew up in upstate New York, and I used to cross-country ski on the Tug Hill Plateau. And if you want to know where the most intense snowstorms are in the world, it's on the Tug Hill Plateau in upstate New York. So we did a field program there several years ago. We were there for 2 months, and we observed 4 storms that had snowfall rates that exceeded over 4 inches an hour. And you know, Alta just had an event a couple days ago where they got 5 inches an hour for 1 hour. But if you want to see intense snowfall, Tug Hill Plateau is one of the best places you can go in the world. These are some of the most intense snowstorms. Also, they come off of Lake Erie, so that lower right-hand corner there is one of these lake effect snow bands. We call these long lake axis parallel bands. These are snow bands that come right down the axis of the lake, usually into just a little bit south of Buffalo. And the gradient in snowfall can be unbelievable. You can see it's not even snowing where this picture's taken. If you were to drive into that, you would go from no snow to 5 inches an hour in about 1.5 kilometers, so in about a mile. It's incredible, the transition that you can have across these. And then if you want to talk about world record snow, you know, probably the snowiest parts of the world are either going to be kind of on the west coast of Japan, which we'll talk about in a minute, or in the mountains near the Pacific coast of, you know, basically Western North America, British Columbia, maybe parts of Southeast Alaska. But the one place where they measure in that area and where the official world record snowfall is Mount Baker, which is in northwest Washington State in the North Cascades. And they observed 1,140 inches of snow in the 98-99 season. And they shared that photo with me, which is incredible to look at that. I don't know if that's a Toyota Tacoma or a Ford Ranger, but you can see the snowbanks there. And that's over the course of a season. So that's July 1st to June 30th. So pretty incredible. And remember, that's all high density snow too. That's why they get these incredible snowbanks. A lot of people love to ski in the Alps. The Alps are the kind of the birthplace of alpine skiing. But unfortunately, the Alps are oriented more east to west than they are north to south. And as a result, it's a lot harder to get upslope flow in the Alps. If you've skied in the Alps, or just a little bit of background on kind of the climatology of the Alps, the wettest parts of the Alps are actually not in the alpine interior where the highest mountains are. The Alps are so high and they're so broad that storms tend to drop their moisture on what they call the alpine rim, which is the northern rim and the southern rim. So in this picture, it's an average annual, this is rainfall, not snowfall. But if you go to a place like Austria, or you're in the Dolomites, it's actually wettest on the southern rim of the Alps and on the northern rim of the Alps. And when you get into the alpine interior, then you get a lot less precipitation. So one of the paradoxes of the Alps is if you really want to have the greatest likelihood of snowfall, you might go to a place like the Arlberg. The Arlberg is one of the snowiest parts of the Alps. It's in western Austria. Ski areas there would be, or the villages there would be St. Anton, Lech, Vart. And that's very snowy because it's in this rim area where it gets a lot of precipitation. On the other hand, it's also lower elevation. So there's a heavier snow. Sometimes you get rain on snow. You get more consistent snow conditions in the alpine interior at high altitudes, say at a place like Solden or Obergurgl, but they don't get as much snow. So one of the paradoxes of the Alps is kind of a little harder to find deep powder there on a regular basis. But the greatest snow climate on Earth is in Japan. I always tell people, greatest snow on Earth is in Utah, greatest snow climate on Earth is in Japan. There's no place like Japan. It's simply incredible. If you're interested in reading more about it, you can hold your phone up, and that's a QR code there. And you can take it to a techie paper that I wrote for the Bulletin of the American Meteorological Society with Sento Nakai, who's a Japanese snow scientist that talks a little more detail about Japan. But what happens in Japan is they're downstream of the biggest continent in the world, Eurasia, and they're downstream of the Sea of Japan, which is 12 times bigger than Lake Superior. And it has a warm current that flows up into it all winter long. So what happens there is they just get pounded during what's called the winter monsoon, which runs from about December to early March. And during that period, they get lots of cold air outbreaks from Asia. They move over the Sea of Japan, and this produces sea effect snowfall. So very similar to lake effect here in the United States, except the air masses are even colder and the body of water is even bigger. So you get enormous amounts of snow, which is sometimes low density depending on where you are. So like I said, what's so special? We call it the Gosetsu Shitai. That's Japanese for heavy snow region. So all those things I just mentioned, and these sea effect systems, unlike the Great Lakes where they're running into small terrain features like the Tug Hill Plateau, they're running into bigger terrain features, right? Stuff that you can actually ski on. And in places like the Hokuriku region, you know, the mountains get up to 3,000 meters in the northern Japanese Alps. So this is running into really big topography. So their seasonal snowfall totals are unbelievable. Sapporo, at 56 feet elevation, is the snowiest city in the world with a population over 1 million people. Mean annual snowfall of 248 inches. Now, it's gone down a little bit. These numbers are from, 1980 to 2010. They've gone down a little bit because Japanese snow is very sensitive now to global warming. And near sea level, they're starting to see declines in snowfall. But the snowiest inhabited place on Earth is Sukayu Onsen, which is at about 3,000 feet elevation. It has a mean annual snowfall of 694 inches. Okay, the snow depth there right now, they're at record snow depths. The last I checked, it was over 4 meters already, and that was like at the end of December. It's just unbelievable. Sunan. Now here's the thing I like to think of. Sunan's 1,500 feet elevation, 37 degrees latitude, which is about the same as San Francisco. Average annual snowfall is 531 inches. Okay, so imagine the hills around San Francisco getting 500 inches of snow a year. Okay, and or comparison I like to do for St. George, which is 2,700 feet. It's also at 37 degrees latitude. So this is incredible that it can snow this much, and most of the snow falls in about a 3.5 month period. Okay, so I like to do this comparison between Sukayu Onsen and Alta. If you look at the December to February snowfall averages, Sukayu Onsen averages 467 inches. Alta averages 238. Okay, and if you look at the annual, it's 694 versus 507. So the surest bet for deep powder skiing anywhere in the world is in Japan, near the Sea of Japan. Okay, and I've never done this in the spring, but in the spring the Japanese open this thing up called the I think it's supposed to be, is that the Hakata Snow Corridor? That might be a typo. This, I think I might have some something. We moved this to a different computer, and I think some of the symbols are getting misinterpreted. But this is a snow corridor that runs through the northern Japanese Alps. They open it in April, and it's world famous for these towering snowbanks because it's at high altitude in the Japanese Alps. So apologies that this looks to be a little bit messed up. Now, there are serious societal impacts of all this snow. Imagine living in a city of 1 million people or more than 1 million people that gets 250 inches of snow a year. Where do you put it? What do you do with it? Japanese have developed incredible infrastructure to deal with it. And several years ago, I went to Nagaoka. There's a research group there, the Nagaoka Snow and Ice Center, that specializes in snow and avalanche research. And what was interesting there, this is from 1963. I'll talk about that in a minute. But they use a lot of water to get rid of the snow. A lot of the snow that falls there falls at temperatures that are near 32 Fahrenheit, 0 Celsius. And they have a lot of geothermal in Japan. And so they have these little pucks that come out of the streets, and they spray this warmer water off, and it all runs off. And that's one of the things they do for snow removal there. Yeah, well, it doesn't get really cold there. It's really close to the Sea of Japan. But they also have a lot of, at lower altitudes, a lot of what we call interannual variability in snowfall from year to year. And they episodically, every 10, 20, or 30 years, they get these enormous snow years, like this year's one in the mountains. And they're oftentimes referred to as snow catastrophes because they have so many people that basically a lot of people die from shoveling snow or from other kinds of incidents. This is from 1963, the Gosetsu winter, so the heavy snow winter. 231 fatalities nationwide in Nagaoka City, 69 feet elevation, 37 degrees latitude, 125-inch snow depth. 125-inch snow depth. And I'd like to show this video. This is from Nagaoka in 1963. Look how high density this snow is too. I mean, this stuff is like, 20, 25% water content. Anyway, pretty incredible stuff, but real societal impacts. As skiers, we always think about the powder, which is great, but these cities they really have to deal with an incredible amount of snow, and in bad years, it can be a big problem. So I like to say that, basically Japan near the Sea of Japan is the surest climatological bet for deep powder skiing anywhere in the world. But they also observe some of the world's deepest seasonal snowpacks. Their snowpacks can get over 7 meters deep. Apologies, let's see, that's 25 feet total depth, pretty incredible. in certain situations. The photo there on the left was taken in the Miyoko-kogen after they had 80 inches of snow in 2 days. Okay, and I'll never forget it. Basically the Japanese ski patrollers there were begging people not to ski outside the resort boundaries. Avalanches weren't the only concern; suffocation was another. You get lots of really deep, low-density snow. And it hadn't snowed a lot yet that year, so it had buried a lot of brush, and people were cavitating, like breaking through. I mean, complete insanity. So my tips for going to Japan is snowfall is greatest near the Sea of Japan. It sometimes decreases rapidly with inland extent. Sometimes, if you're there and you're in a place like the Hakuba Valley, you want to kind of find out the ski report, and you don't always want to go where they got the most snow because sometimes they've had too much. And sometimes you kind of want to play the game of, where do I want to be to get the best skiing? And strong flow is needed for deep inland sea effect penetration. So if you're in the interior, those tend to be windier storms that can also be problematic. You don't always want to be where it snows the most. That's what I learned on the Miyoko-kogen. 80 inches of snow. Yeah. Yeah.
How do they do avalanche control if they don't use explosives?
Well, I've heard that before, but I don't know if that's actually true. It could be. But a lot of Japanese ski areas are pretty low angle. So I don't know if you've ever heard the line, I'm trying to think what it is now. It's like, what is it? What is it? There's a joke line, I can't remember what it is, but it has to do with the low angle skiing. Deep, it's deep, not steep. That's what it was. Thank you. When I've gone ski touring there, we've gone above the ski resorts in the steeper terrain. And I remember once we went to Sugayuke, I think it's called, which is in the Hakuba Valley. This is the longest beginner run I've ever seen in my entire life. I think it was a gondola. We rode like 3,500 vertical feet over like 15-degree slopes. And so, but I don't know what they were doing. I mean, when I skied in the Miyoko-kogen that day, and they were begging people not to go out of bounds, everything I skied in the resort was not really avalanche terrain, mostly low angle. Yeah, I mean, that was the problem there. That was not, I can tell you I've had lots of really great powder days, but that particular day was actually not one of the better days. You were better off skiing where it had been cut up, right? Because it was just, not enough hill to ski. Yeah, but when it's snowing that hard, nothing's really groomed. So, all right, I want to conclude with a little bit of talk about climate change. And I have a couple chapters called Withering Winters and the Fate of Skiing. And one of the good things here in Utah is we're higher elevation. I'll talk about this in a minute, but we're not quite as sensitive here as other parts of North America in terms of vulnerability to climate change. But climate change is happening. This is global average temperatures going back to 1850 for every year. And you may be aware that 2023 is the warmest year in the instrumented record. And we've warmed approximately 1 degree Celsius or 1.8 degrees Fahrenheit above the 20th century average. That's like the average global temperature over the last decade. And 2024 is going to be warmer than 2023 by a small amount. 2025 might drop a little bit. We're not quite sure yet what's going to happen. There are these fluctuations from year to year, but you can see the long-term trend is a warming trend. And, basically an intergovernmental panel on climate change, which tries to summarize all the climate research, states it's unequivocal that human influence, global warming due to the increasing greenhouse gases and other human effects, have warmed the atmosphere, the ocean, and the land. And there's been widespread and rapid changes in the atmosphere, the ocean, the cryosphere, the biosphere. So for skiers, the big thing that people notice is snow and ice change. And where you really see it is if you go to a place like the Alps. And the Alps have seen very dramatic glacier retreat over the last several decades. There's actually been long-term glacier retreat as we've emerged from the Little Ice Age in the 1800s. But it's considered to be global warming from human influence is the primary driver since about the 1990s. And I spent 6 months in Austria, and for Austrians, this is a kind of an insult to their culture. I mean, they're really concerned about losing these glaciers. Impact of skiing, it's kind of interesting. Summer skiing was a big deal in the European Alps. And in the 70s and in the early 80s, a bunch of resorts started operating during the summer. Maybe not for the whole summer, but for part of it, either for ski team training or just for pure recreation. And there were 32 operating glacier skiing resorts in the Alps by 1985. And today there's only a handful. And there's only one skier in the world that's still able to stay open all year long. That's Hintertux Glacier in Austria. And Zermatt used to stay open all year long, but the last 2 summers they've had to shut down. And that's part of global warming. When we look here in the Western United States, these are trends in April 1st snowpack water equivalent, so the amount of water in the snowpack as a function of altitude across the whole Western United States. What I like to tell people is, global warming is not an equal opportunity offender. It has a bigger impact on snowfall and snowpack in warmer, lower altitude climates, and a smaller impact in colder, higher altitude climates. And that's what you see here. You can see that these red dots, the ones that are far to the left, those are where there's been the largest change, the largest declines in snowpack. And you can see how that's larger at lower altitudes. And then when you go up higher, the trends are a bit smaller, okay? When you go to a place like Alta, rainfall at Alta at the base is still pretty unusual during the winter. So from like November 1st till the end of April. Every now and then they get rain all the way to the base of Alta. But if you go down to the Salt Lake Valley, for example, we're seeing a lot more of our wintertime precipitation falling as rain instead of snow. I think Salt Lake City Airport's only had a few inches this year. Now this year has also been maybe warmer than average too. But we're seeing this trend now, and it's not an equal opportunity offender. It's much more of a bigger risk at lower altitudes than at higher altitudes. And just to kind of show that, this is some work that one of our graduate students did with, her name was Lee Jones, with John Horrell in my department, where they were trying to determine what fraction of the precipitation that fell as snow, say in the 80s and the 90s, would instead fall as rain with every degree of warming, okay? And so they put this plot together. So this is the fraction of precipitation from the wintertime that previously fell as snow that instead would fall as rain with 2 degrees of warming over what we had in the 1980s versus 4 degrees Celsius of warming. So these areas in red, you're seeing losses of up to 50% in snowfall, and that includes the base of Park City. So Park City, right here in town, if the local temperatures increase in the wintertime by about 8 degrees Fahrenheit, you would lose probably half of your seasonal snowfall to rain, okay? And then, of course, the snowpack is worse than that, right? So this is just if we held everything else fixed. On the other hand, when you go to Alta and Snowbird, they're in the catbird seat in terms of their being least vulnerable to climate change. And still at their upper elevations, a large fraction of the wintertime precipitation would still be falling as snow even with 4 degrees C of warming. So there's tremendous pressure on the cottonwoods now because it's still, it's like the most snowfall and in a marginal year. That's kind of where people want to go. I've always kind of said that that's only going to increase with time because the higher altitude snowy terrain there is going to become even more valuable with climate change. And this is just to kind of highlight that a little more. This is a study that was done by a group at the University of Wyoming looking at changes during the wintertime in days with a mean temperature that's above freezing, changes in days with rain of more than 0.04 of an inch. And the right is the change in the number of days during the core operating season for the ski areas with at least 8 inches of water in the snowpack. Areas in red experience the largest trends due to global warming, and the areas that are in yellow are the smallest. And you can see here, like Summit County, Colorado, is going to be the last place where we're going to have reliable snowpack if global warming continues unabated, okay? And then also upper elevation Utah works out better than, say, parts of the Pacific Northwest in the interior. So global warming is not an equal opportunity offender. So with that, I'd like to just knock off. I don't always do climate change because it gets a little depressing, but I find there's a lot of interest in it. You can follow my blog, Wasatch Weather Weenies. That sometimes can be kind of techie because I write it sometimes for meteorologists, but it's a fun thing to follow. Sometimes I do forecasts, that sort of thing. You can follow me on X or Twitter at Professor Powder. Also, I'm on, what is it called? Blue Sky now? Yep. And if you're interested in picking up the book, there's some up here. This is the first edition. Second edition is also out. And Dolly's here in town used to carry it. I don't know if they still are right now, or you can get it on Amazon and Barnes & Noble. I'll be happy to answer questions. Thank you very much. There is a request that we ask questions into the microphone if we can pass it around really quickly. So it won't pick up though for the recording. That's the challenge. Do I have, oh, the microphone's up here. Let me start here then.
What fraction of the Wasatch snow, and I assume it depends on the canyon, depends on the lake effect? And to what degree is that at risk as the Salt Lake diminishes in area?
Yeah, it's not as much as people think, but we did a study several years ago, and we found that at Snowbird, I think it was somewhere between 5 and 6% of the water equivalent snowfall that falls comes from lake effect storms. So it's probably less than 10%. The period we looked at, the lake was already a little bit small. So it's not as large as people think, but it is that's definitely at risk. So it's another piece that could go away with time. And the other part of that can be important is as the lake shrinks, it becomes the playa, what they call the playa around it becomes a potential dust source. And when dust gets into the snow, in the springtime, when the snow melts, the water percolates through and all the dust ends up at the top. And dust absorbs more sunlight than natural snow, so it actually accelerates the snow melt in the spring. So those are two of the things that the shrinking Great Salt Lake could affect. Actually, the most lake effect is in Little Cottonwood, but it's also in the Ochre Mountains, which are to the west of the Salt Lake Valley, about the same amount, but it ends up being a greater fraction of their seasonal precipitation because it doesn't snow as much in other storms in the Ochres. So can we throw it in the back and then we'll bring it back up front?
Yeah, you were talking about the area in Japan that has so much snowfall and that 1 million people live there. Why?
Well, this is a skiing audience. That makes a lot of sense, doesn't it? I mean,
what industry is in that area? Obviously, there has.
Oh,
to
I've
be
never
something.
been to Sapporo, so I don't know the answer to that. I've only been to the Hokuriku. And
I was just thinking, winters like that, there has to be some other draw for 1 million people to live in that. So.
Yeah. I mean, I don't know. I mean, Sapporo's a big city. I don't know Japanese economics. I studied the snow more than that. So, but that's a good question. Yeah, sake. Yeah. Let's bring it up here then.
Can you give a quick review of champagne powder?
The champagne is a trademark slogan of Steamboat Ski Area. I'm not allowed to comment on that without. No, but I believe it is trademarked by Steamboat, and that's their phrase for their local low density snow, low water content. Yeah.
Do we get the low density snow as well?
Sometimes. I mean, Steamboat's average water content is a little lower than Alta's, so I think if the observations that I've seen, I think the average water content of snow in Steamboat is 7.2% and Alta is 8.4%. And I think part of the reason for that is Alta still gets snow in these warmer southwesterly flow storms, and Steamboat doesn't get quite as much in those. But they also get less snow, but they're famous. That's their trademark. I don't know if you know this, but I think Ski Utah was using Ski City USA for a while for marketing, and Steamboat is Ski Town USA, and that was trademarked as well. And I think Utah got slapped on the wrist for that. So yeah.
Thanks. Just a quick question on myths. There's always these statements that you read. It's usually at the beginning of the year or in the summertime, and they'll say, it's a good year. It's going to be a good year because it's a El Nino year, or it's a La Nina year.
Yeah.
What does that mean?
Doesn't mean anything.
Doesn't mean anything.
So let me talk about that. For northern Utah, it doesn't mean anything because we are in between this kind of what we call the seesaw. Okay, so if you average over lots and lots of La Nina events and lots of El Nino events, La Nina years tend to be better for snowfall in the Pacific Northwest. They tend to be not so good for snowfall in the Southwest, right? And we're on this kind of the fulcrum of the seesaw there. So we're in the transition zone. So it has no predictive value for what's going to happen for snowfall around here, 0. So what I usually tell people is a good year in Utah is better than or a bad year in Utah is better than a good year in Colorado. So stop worrying about it and ski it if it's white. There's been some work done in my department trying to see if we could get a better handle on seasonal forecasting. If we could reliably predict how much snow is going to fall in a given winter, or better yet, maybe over a 10-year period, that has real value for water management, for example. You know, like basically if you're managing a reservoir or series of reservoirs, you know, like right now, I mean, we've been in this kind of mega drought in the Southwest United States. There's a lot of concerns about that, say, being a problem in the long run because of the warming, evaporation, you lose a lot of water, that sort of thing. But if we were to say have a 10 years where we got wetter again for a while, like the 80s, which I think is unlikely because the tree ring data suggests the 80s was a really unusually wet year if you go back even hundreds of years, or wet decade. But if we could have that, it would make a big difference for a while. So it's important, but yeah, we really don't have any predictive skill for what's going to happen in any given winter. But there's a lot of people that make money saying they can do it. So
just as a follow-up then, because I'm originally from Oregon and I understand they're having a, you know, bang up year this year in Bachelor and Mount Hood.
yeah,
Is that because of El Nino, or could you say that
it's not an El Nino. You're right now.
So it's a La Nina.
So but the thing is that people, we have a line I like to teach my students, which is all generalizations are wrong. Okay, so El Nino shifts the odds about 5%. Okay, and so for instance, you remember the 22-23 winter, like Alta had 903 inches of snow. And I can't remember if it was an El Nino or a lot. I mean, if you look back and look at that, it's a black swan event. It doesn't make any sense relative to these generalizations that people make. So my view is that the amount that it shifts the odds is not super large. And we need to be really careful, even in these areas that are in more controlled, like have a stronger correlation. The correlations still are not huge. And there's definitely been a lot of egg on the face of seasonal forecasters over the years by just plotting, this is what happens on average, and suggesting that's what's going to happen. I usually tell people it weights the dice a little bit, but not a lot. You know, like even with global warming, you have to be really careful with that. It's weighting the dice. But if you get into a jet stream pattern that's relatively cold, you can have a pretty cold winter. It can still happen. It's just that the dice have been loaded. Yeah.
So were you consulted on this East Valley, Deer Valley new property for potentially having a lower elevation and also at mostly east facing?
No. You know, I get asked that a lot. There was some talk about building a ski area in the Oakers for a while. But ski areas get built for all kinds of reasons besides snow. And yeah, I mean, they're building that resort in an area that's not going to have a lot of natural snow. They're going to have to make a lot of snow there. It's you know, I mean, if you go to Jordanelle Gondola Base there, you know that the natural snowpack there is pretty scant, and I would expect Mayflower's pretty similar climatology. So I think it goes to 9,000 feet there, but those ridges are also farther downstream, say, than the area up around, Empire, whatever their highest chair is there. So it'll snow less even at higher altitude there. Yeah. I mean, the closer you get to the crest, the more the snowfall is at a given elevation.
Canyons similar to that?
Canyon snowfall at the base of the canyons in Park City is probably a bit more than it is at Jordanelle, but it's not a lot. I don't think that it depends on exactly where you measure it. Like if you measure it in eastern, like you go a few miles to the east here, it's going to be a lot lower than if you measure it right at the base of the mountain. But it's moving into a drier area. And then the lower altitudes too, when you start getting below 7,000 feet, that's an area that's going to be more vulnerable to seeing more rain on snow events in the future. Yeah.
How relevant is the powder buoy?
That's a loaded question. Is a powder buoy person here? Yeah, I think the way I would put that is there's probably a teleconnection there. There's, you know, like the waves in Hawaii reflect storm activity in the Pacific. So I wouldn't be surprised if there was some level of correlation there. But the reality is modern weather prediction it does a lot better than that. You know, like if you look at the products that we produce on weather.utah.edu, I have this product called the Utah Snow Ensemble. And, you know, that's based on 82 computer forecasts for the whole globe And these computer forecasts collect data from 20 million locations for every computer model run they do. If you look at a modern computer forecasting system that forecasts for the whole globe, the European Center for Medium Range Weather Forecasting, which is the best forecasting center in the world, they collect 80 million weather observations a day. Okay, and 20 million of those go into their forecast models. Those observations are not just surface observations. Most of them are from space. Over 99% of the observations now come from satellite. Satellites are the backbone of modern weather forecasting because we can observe, incredible, swaths of the world with them. So yeah, it's kind of a nice story, and it's kind of cool if you want to follow it, but it's not going to be as good as what we can do with modern numerical weather prediction. And the big breakthroughs now are happening in artificial intelligence. So there's a number of groups around the world now, Google, NVIDIA, and they're developing what are called MLWP. So we used to call numerical weather prediction is solving mathematical equations that are based on laws of physics to predict the weather. MLWP is machine learning weather prediction, where they're using statistics to do it, although they're doing training with analyses that are created using these physically based models. But they're able to produce, for example, a forecast now for, say, the winds at jet stream level that's just as accurate as our really complicated numerical models in 1/1000th of the time. Okay, so I think we're going to see the next 10 years are going to be the most transformative of my entire career because there's so many exciting things happening on the weather prediction front right now. So,
are we getting more warm storms, atmospheric rivers that are coming from southerly areas than the cold storms coming out of the Gulf of Alaska?
I would just change that a little bit. In other words, that the average temperature in storms is increasing. Okay, and that's happening in all the storm types. So we get these. So atmospheric river is a relatively new phrase. So like it was first used in a scientific article in 1992, and it really didn't start to catch on until about 10 years ago in the public vernacular. So you hear this all the time, but it's not like atmospheric rivers are new. They've always been going on. It's just a new phrase. But with climate change, we would expect that atmospheric river intensity is probably going to increase, which in terms means that you're going to get heavier precipitation periods. But the warming in storms is probably happening across the board. Even the cold northwesterly flow maybe on average isn't as cold as it was before. So all storms are warming. And we have some data from Alta, and you can see that the density of snow there is increasing as well, which is what we would expect as the temperatures go up, is you'll start to see it shifting towards higher density snow. What happens in any one year depends on the winds of the jet stream. So there's a couple questions over here.
Can you do a quick comparison between the northern and southern hemisphere, how each is changing with climate change?
So probably the biggest difference is the difference between the Arctic and the Antarctic. So the Arctic is the fastest warming region on the planet and is experiencing really dramatic change. Okay, Antarctica has not had that fast of a response, and I'm not an expert as to why that is, but that's been what our computer models have been forecasting. So our climate projections that were based on computer models have expected the Arctic to warm a lot faster than the Antarctic.
What about like ski resorts in Australia and New Zealand?
Yeah, I've never really investigated how climate change is affecting those resorts. I mean, they're lower elevation, they're warmer, they get less snow in general. So I would expect that a lot of the trends that we've seen here in the Western United States is probably happening there as well. And probably also especially in the Southern Andes, like Patagonia and that area. Glacier retreat is something that's happening all over the world, with the exception of a couple of really local regions where maybe they've had exceptional snowfall in the last 10 years. So for the most part, this is happening everywhere. But whether those resorts are more vulnerable, they're probably more vulnerable than, say, interior Colorado. But I don't know how they would compare, say, to what we're seeing here. Yeah.
Thanks. Do you have like one or two top common sense policy recommendations, say for the state of Utah, around some of these issues, or is it just a bigger problem than that, and there's really not a lot we can do?
You mean in terms of addressing global warming?
Yeah, so I can have more snow.
Well,
So
you
my
might be
kids-
interested to know that the state of Utah has increased its spending on cloud seeding from $350,000 a year to $5 million a year.
Is that a net? Is that good? What is that? Does that work?
It's extremely controversial. The effectiveness of cloud seeding is extremely controversial in the meteorological community. I'm going to just leave it at that. Yeah, I mean, it's a big how do you convert a fossil fuel economy into a clean energy economy? It's a really hard, it's a hard problem. What do they call it? A wicked problem, whatever. I mean, it's hard to do. And yeah, I mean, for me, people ask me what I do is I just try to make my, I have solar on my house. I've just put in a heat pump. I just try to make the personal choices that I think are right for me and hope for the best. But I don't know, Utah's talking about investing in nuclear, and other things. I don't know what they're going to do, but we're going to have a much warmer planet if we don't transition out of fossil fuels.
But so things like changes in agriculture, things like that, outside of their fossil fuel use, aren't really going to have a meaningful impact on the amount of snow we get.
They would, if globally
In Utah, though.
If global carbon dioxide emissions went down substantially, all greenhouse gases, if we dropped them substantially, global warming would flatten out eventually, and it wouldn't be that as large as it's going to be if we continue with business as usual, so to speak. You can kind of think about it as, like a lot of people have talked about 2 degrees warming, trying to stop it there. That's not a number I think of. I just think about it in the standpoint is that the more carbon we put into the atmosphere, the more the warming is going to be and the bigger the adaptation we're going to have to do. So if you look at it from the standpoint that we're going to be doing both adaptation and mitigation, the more mitigation you can do now, maybe the less adaptation you got to do later. And yeah, if we were to substantially reduce greenhouse gas emissions globally, say in the next 10 years, it would probably allow skiing to continue in the Wasatch. Granted, at warmer temperatures than we have now, but it would allow it to continue. I think I talk about this in the book a little bit too. So.
It's hard to ask you a prediction that's 10 years out, but we do have an interest here about 2034.
Yeah.
Would you like to comment on what you think we might be looking at in 2034 versus
It's going to snow a lot. They're going to have all the venues prepped, and then it'll be clear skies for 2.5 weeks.
Is that the same prediction you did in 2002?
Yeah. 2002 was kind of interesting. Dave was involved. I forgot to mention, Dave and I first met in Nagano for the '98 Olympics. We were part of the group that the Salt Lake Olympic Committee sent over to kind of observe the Olympics. And for me, I was looking at weather support and how, what needed to be done for the Olympics and how to build better forecast systems. But what I remember about the 2002 Olympics is, number one, the valley was incredibly polluted the week before the Olympics. It was a really awful air quality event. And I had to give a talk on Olympic weather support after the governor of Utah, Mike Leavitt, talked, and after the Secretary of the Interior talked. And then it was me talking about the weather. And everybody wanted to know about the air quality, right? But then the day before the Olympics, a front came through and it cleaned everything out. And we had great air quality for the Olympics, but we also didn't get a lot of big snowstorms, which is what you want. For the Olympics, you actually don't want it to snow very much. Everybody talks about, snow, whatever. No, none of the outdoor venues want snow, okay? Once the Grizzly downhill at Snow Basin is prepped, and it's icy as hell and you can't walk on it except with crampons, they don't want it to snow because they're gonna have to pull all that snow off. So for most of the venues, maybe freestyle might be a little different. I'm not really an expert in that because they might not want it quite so firm. But you don't really want a lot of snow. It creates transportation problems, it creates venue issues. But you also don't want a ridge around here because that means the valley's gonna get polluted. So you want that kind of the best of both worlds. I have no idea what's going to happen in 2034. When I can tell you that the people that put on the Olympics maybe this time around they'll be a little more in tune to it. But oftentimes they don't worry about the weather until like right before the Olympics. And now all of a sudden it's the most important thing that they can imagine. So when we used to meet with them, we had this hit list that we put up on a PowerPoint slide of what happened during the Olympic period in the past. And it's like 1985, like 200 inches of snow at Alta, you know, to get them to start thinking about what might happen, but we'll see. I think in 10 years, sometimes people are worried about snow. I'm not worried about snow at most of the outdoor venues for the Olympic period, only because it's in February. There'll be time to make snow. It's high enough altitude. I don't think we're going to have a problem even in 10 years. I worry a little bit about Soldier Hollow for the Paralympics. I mean, I suspect at Soldier Hollow, they're going to reinvest in snowmaking there, and they'll be able to, because it's in that cold valley, they'll be able to deal with enough for cross-country skiing for the Olympics. But the Paralympics are in March, and that makes me a little more concerned. That's our most vulnerable outdoor venue is Soldier Hollow. So
the rule is for the biathlon, it can't be above 6,000 feet.
it's 1,800 meters, I think. Is that what it is? 1,800 meters? Yeah, I think it's like a little under 6,000 feet. I mean, the best natural snowpack for cross-country skiing in northern Utah is probably in the Ogden Valley. So, you know, if anybody's ever gone up there to go skiing, you know, the great cross-country center that they have for the Ogden Nordic runs there, there's a yurt there. They have way more snow there right now than we do. It's an enormous snowpack there. That's the best natural snowpack. Dave can tell you why they picked Soldier Hollow. I don't know why that was picked. Oh, I'm not sure. I think they may be under Olympic level at Ogden Nordic, but it's pretty close. So. The Norwegians might have to give up on this altitude thing eventually if they want to continue to have competitions. I mean, all around the world. I mean, a lot of the lower elevation resorts in the Alps are really struggling for snow now. And if they want to continue to have biathlon and cross-country competitions, they're probably going to have to start thinking about moving them to higher altitudes. Yeah.
Okay, it's a geek question. You prefer ECMWF versus GFS? You kind of said that.
So the
And
ECMWF.
Will GFS ever catch up then, or?
No. The United States has a tremendous amount of work to do to be the premier center of weather prediction in the world again. When I say that, I mean computer weather prediction with models. The ECMWF has some substantial advantages over the United States in that they have a very narrow focus. That's all they're called the European Center for Medium Range Weather Forecasting. So they focus on like 2 to 20-day forecasting. And that's the only model that they have, and that's the only model they develop. Here, the United States has such complicated weather. We've got tornadoes, we've got severe convective storms, we've got hail, we've got hurricanes, we've got winter storms. So the United States runs multiple computer models. There's a lot of challenges. And the National Oceanic Atmospheric Administration is really doing lots of stuff. And I think that it's a lack of focus that's part of the challenge here in the United States.
So you'd use the HRR until the 2D and then the ECMWF.
Yeah, the HRR, that's the HRR, the High Resolution Rapid Refresh. That's the US's high resolution model. And that tends to be a short range model. But I look at all the models usually for any time I'm looking at it. We tend to look at lots of them. But just to give a comparison, say in the mountains, the United States runs their models with grid cells that are 3 kilometers on a side. So they average everything in that 3 kilometer box. You think about that's 1.5 miles or 2 miles on a side. And they run one forecast. That's the HRR like that. Okay. The Swiss, they run at 1 kilometer and they run 10 forecasts. Okay. Because the Swiss care about mountain weather a lot. So, and the U.S. has also gotten way behind because NOAA decided to invest in a new modeling system. And when they did it, there were a lot of concerns raised by the academic community that particular approach that they were going to use was not going to work when they go to higher resolution. And it's taken them several years now, but now they finally realized that they're going to have to go to a totally different system. So a lot of challenges.
As far as your customer, other than the recreation and skiing, I mean, we were talking about skiing. Is skiing the biggest customer, or like snowpack in the Rockies affecting building permits in Arizona.
I'm an ivory tower academic. I don't have any customers.
Yeah.
I often tell people I don't make the products you buy, I make the products you buy better. So like that was a BASF. I don't remember that company. They always used to say that. And so I use forecasting as a sandbox for me to experiment with forecasting techniques. But snowfall forecasting is really important for lots of things, like transportation, for example. UDOT was the first state Department of Transportation that embedded meteorologists in their operations center. Okay, and they still have forecasters that are embedded in there all the time. Having the plows on the road when it starts snowing is really important. Minimizing salt usage is really important. Minimizing, say, hours that you have people out there plowing the road is important. All these things come down to it. So there's lots of stuff there. On the building side, that's totally outside of my area. I know in Austria, the Austrian Weather Service, which is now called Geosphere, like they operate as a quasi-private company, and they go out and they do all kinds of consulting, including load issues for buildings that are being built in the Alps. But the National Weather Service doesn't do anything like that. I don't know what groups do that, civil engineering firms probably and stuff like that, but I don't know anything about that. So, well, if that's everything, thank you for coming out. And think snow, because we need it for skiing and we're going to need it for water. So.